and welcome back to my channel. Today we will be starting our new chapter of kinematics ES physics. Okay, 9702, and today this is our second chapter. We have already completed our first chapter. Okay, so if you want to learn that chapter, do watch my previous videos. I have the full playlist of ES physics. Okay, so let's start this chapter. Okay, so first, we have the concept of the difference between distance and displacement. Okay, so distance is the total length covered, okay, by an object. It is the full length irrespective of the direction. That is why we call this quantity as scalar. Okay, distance is a scalar quantity and its unit is meter. On the other hand, displacement is the shortest distance in a specific direction between initial and final position. Okay, it is a vector quantity because it has a direction. Okay, displacement can be negative or positive. Negative displacement usually means that you are moving in backward direction. Okay, similarly it has a unit meter. Okay, so these are some differences. You can see this diagram I have drawn here. So from A to B, if you are moving, okay, this purple curved line is a distance. Okay, it is a path. It is irrespective of the direction, and displacement is the shortest distance, okay, between these 2 points. So I have already written here that this displacement is the shortest distance. Okay, so you need to remember these two terminologies and the difference between them. Okay, sometimes it has been asked that how displacement can be zero. Okay, so you should know that if a person goes from A to B, okay, and then returns through B to A on the same path, then its displacement would be zero. Okay, not distance, only displacement would be zero. Okay, so I have a MCQ here. Okay, let's try to solve it. One object moves directly from P to R, okay. In a shorter time, a second object moves from P to Q to R. Okay, one object is moving from P to R directly, and a second object is moving from P to Q and then to R. Okay, so which statement about the two objects is correct for the journey P to R? So we can see they have same average speed. It is not necessary. They have same average velocity. No, because second object is coming in a shorter time. Okay, they have the same displacement. Yes, they have the same displacement, and in the D it is written they travel the same distance. No, it is not correct. You can see if this is 5 meter, this is 5 meter, okay, and this is 6 meter. So this distance would be 10 meter altogether. Okay, this one, and this is 6. So the distance is not same, displacement is same, because displacement is what? The shortest distance. And shortest distance P to R is only this one. Okay, so C would be the correct answer. So this was all about the distance and displacement difference. We will look into what is speed and velocity. Okay, so speed, you know that it is the distance covered per unit time. Okay, how much distance you are covering per unit time, or you can say change in the rate of distance. Okay, so it is a scalar quantity, it has no direction, and its unit is meter per second. Okay, we all know that, we all have been learning these terminologies since our O levels and from previous grade as well. Okay, on the other hand, what is average speed? Average speed is when you sum up the total distances, all the distances and all the time. Okay, so it is the total distance covered per unit total time. Okay, so this would be your formula for that. Then you have velocity. Velocity is what? Velocity is change in displacement, not distance. Okay, it is the difference. You cannot write here change in distance. It should always be change in displacement, okay, per unit time. And then you have the formula, okay. This is the formula. On the other hand, it is a vector quantity, okay, and it has unit meter per second. Similarly, if you write minus 20 meter per second, it means that the direction has been changed. Okay, there's a difference between both these two velocities. Okay, because one has a negative sign, which means it has opposite direction. That is why we call it a vector quantity. Then we all know what is acceleration. Okay, acceleration is the change in velocity per unit time. Like how much velocity is being changed. If it's like 2 ms an hour, then 40, then it is 60, then it is 80. Okay, so we can see the velocity is increasing, okay, at a rate plus 20. So we can say the acceleration of the object is 20 meter per second square. Okay, so on every second there is a change of what, 20 meter per second speed. Okay, there is an increase. We have the formula, okay, change in velocity per unit time. Okay, acceleration has formula v minus u upon t, that is final minus initial velocity upon time. This is the formula. Okay, this velocity depends on two things, that is speed. Okay, that is the speed, and the number second thing is your direction. Okay, these are the things on which the velocity depends. And how it depends, let us see the example. Okay, in case one, what is happening, you can see the case one in which the velocity is same, okay, the speed, but the direction is changing. And also in that the object is accelerating. Okay, the accelerated only does not mean that the your speed is changing. If the direction is also changing, it also means that the object is accelerating. In case 2, the velocity, you can see the velocity is changing from 5 to 10, but the direction is same. In that case also, the object is accelerating. Okay, so you need to remember the difference. Okay, then we have two things, that what is uniform acceleration. Okay, it is the constant change in velocity per unit time, whereas non-uniform means when the change in velocity is not constant. As simple as that. Okay, important concept of kinematics, that is equations of motion. Okay, so there are four equation of motions that you need to remember. Okay, all four are very easy to get, to memorize them. Number first is that v is equal to u plus at. Okay, we have already studied this equation, but we have just made the v subject. Okay, I have written here how we have derived this equation. Okay, so you can pause the video and check it out. Okay, it's very easy, nothing any confusing in this. Okay, then second we have s is equal to u plus v upon 2 into t. Okay, you can also check this derivation, how I have derived this equation. Derivation is somehow important. Okay, but you just need to remember the equation, the main equation that is written here. Okay, you just need to remember this. Third is the s is equal to ut plus half at square. This is used very much, okay, in your MCQs. You need to remember this equation as well. Okay. S is here what distance, displacement, u is your initial velocity, then a, it is acceleration, t is time. And how I have derived this equation, okay, if the u is 0, like your object was at rest, so what you will use, s is equal to half at square. Okay, because this would become 0, so you only use this half at square. And our fourth equation, one of the most important equation, okay, v square minus u square is equal to 2as. Okay, and must see how it is derived. Okay, so you get an idea of that. You must remember the conditions that need to be applied, okay, in order to use these equation of motions. Number one is that when the motion is linear, that is straight line, okay, path, not circular. We will study circular motion as well. So the motion should always be straight line. And secondly, that your G should be constant, that is 9.81. Okay, then only you can use these equations. Apart from that, okay, you cannot use these equations of motion. Okay, the past papers. Okay, let's see this one. A car is traveling with uniform acceleration, okay, almost straight road, okay. The road has a marker post every 100 meter. When the car passes one post, it has a speed 10 meter per second, and when it passes the second one, it speed is 20 meter per second. Okay, so you can imagine or visualize it like this. This is a 100-meter post. Here, the speed was initial speed was 10 meter per second, and final was 20 meter per second. So we need to find the acceleration. Okay, so if you look closely at the quantities or the data that you have been given, we can visualize. Okay, we can select one of the four equations of motion, and that one would be v square minus u square equal to 2as. Okay, I will be using this equation because I have all the three quantities except a. So v square is 20, then u is 10, then you have 2a and s. S is your displacement, that is 100. So a would become, okay, if you further calculate the answer, okay, I'm taking the 2. 300 divided by 200, okay, this is 1.5. So B would be your correct answer. Moving body undergoes uniform acceleration while traveling in a straight line by Z. The distance x, y, z are both 40 meters. Time travel from x to y is 12 seconds and from y to z 6 seconds. What is the acceleration of the body? Is a uniform acceleration and straight line, which means we can apply the equation of motions. Okay, so visualize the scenario, given scenario, x, y, z, 3 points. Okay, distance is equal 40 meters and 40 meters, and time taken from x to y is 12 seconds and to z is 6 seconds. We need to find the acceleration. Okay, so xy, from x to y we can implement the equation of motion. Okay, that is s is equal to up plus half a. That will be 40 equal to u is, we do not know u. Okay, p is 12, and here half 80 square. Okay, then from x to z I would take again this equation, not from y to z, because I do not know the initial velocity from y. Okay, so we'll take the whole journey now. So that would be 80 meters and u into now 18, because I've added a total time, and half a and then 18 square. Okay, this is equation 1 and this is equation. Now if you simultaneously solve the both equations, you should get the answer of 0.37 meter per second square. So this would be your final answer for this MCQ. diagram shows experiment. Feather falls from rest. Okay, from rest means that the feather initial velocity is zero. Okay, a long evacuated vertical tube of length L. The feather takes time t to fall from top to the tube. How far, okay, will the feather have fallen from top of the tube in time 0.50 t? Okay, so now we know that u is 0. Okay, the vacuum. Okay, there is a vacuum. Noted here. So g would be 9.81. Okay, and we need to find distance. Okay, so we can use s is equal to uv plus half it is okay, and s is l here, u is utc, okay, and half a t capital T square. Okay, and we can also do the t capital T. It does not matter because it will become c. You are only left with half a t square. Okay, now your time is half of t. Okay, so we need to find the s now. That would be u is again 0. We do not need to find that. A 1 upon 2 of t square. That is 1 upon 8 ab. Okay. Now from equation 1 we can see that ab square is equal to 12 substituted here. Okay, so s would become 2l upon 8 is 2 ones are 2 fours are, and that would become into 5 of l. So b would be the correct answer. MCQ states that object is thrown with a velocity of 5.2 and it vertically focuses on the acceleration given the time taken for object to return to its starting position. Like this first, okay, for layer at the line peak with a velocity will be 0. We will simply use that formula E is equal to plus V. We need to find time, so t subject 0 5.2 and we'll have 1 minus 1.6 because acceleration is will become negative. Okay, so we would get around 3.2 seconds. Now this time is only for moving upwards. Okay, it would again get 3.2 seconds to move down. So 3.2 seconds plus 3.2 seconds will be 6.4 seconds. This would be a correct answer. Then we have a final topic that is the experiment for measuring the value of G. Okay, so you can see here the diagram which shows how the value of G is calculated. In the stand electromagnet, the ball is released and through light gates, okay, the height and the starting and stop time are measured. Okay, so we use this equation ocean. Here S is H, okay, then you have U is 0 because the sphere is at rest. So U 0 and then you will get H equal to half GT square. If I make G the subject, it will become 2H upon E square, where H is height, T is the time taken. Okay, so these are some of the points. H is independent, T dependent, Okay, we can plot a graph of h and t square. These are some basic points, but all you need to remember is distribution. Yes, we have these two MCQs related to this topic. Okay, we have two markers in the MCQ one. We have two markers M1 and M2, that and distance h. Okay, so you can see it is related similar to that diagram that we have previously studied. Okay, which expression gives the acceleration of the ball? So, A is not correct because we need the both the timers. We need a difference between the timers. Okay, so we need to find the difference between the two. Okay, so B would also be not correct. Now C and D, which would be correct? C is not correct because it has whole square. We studied 2h upon, if you remember, it is 2h upon t square. Okay, so we need to do the difference between both the timers. It will be t1 square minus t2 square. So t would be the correct answer. Similarly, on the second MCQ, we can see an experiment is done to measure acceleration of free fall. Which measurements are needed? So we know that the formula is 2h upon t square. So we need h and t. So we need height and time. Okay, so height of fall and time of fall. So A would be the correct answer. So this was the some overview of the concept of kinematics. Okay, in next video we will study graphs and then we will study projectile motion. Okay, thank you.